This is a video from section 4.1. A critical number of a function f is a number c in the domain of f such that either f prime of c equals 0 or f prime of c does not exist. The key part of this definition is that c must be in the domain of the function. Now, I want to give you a visual representation of this definition. In the first drawing, I want you to notice that at x equals c, we have a horizontal tangent line. And the slope of any horizontal line is equal to 0. And so what that tells us is that f prime of c equals 0. Now, let's take a look at the second drawing. The limit as h goes to 0 from the left of f of c plus h minus f of c divided by h does not equal the limit as h goes to 0 from the right of f of c plus h minus f of c divided by h. And so what that tells us is that the limit as h goes to 0 of f of c plus h minus f of c divided by h does not exist. And so that tells us that f prime of c does not exist. And with that, let's take a look at some examples. The directions say to find the critical numbers of the function. And we want to take a look at problem number 29. On 29, we have f of x equals 3x squared plus x minus 2. The domain of the function is negative infinity to infinity. Okay. Now, let's take a look at the derivative. The derivative is 6x plus 1. We're going to set f prime of x equal to 0. And so that says 6x plus 1 equals 0. 6x equals negative 1. If I solve for x, I get x equals negative 1/6. And I want you to notice that negative 1/6 is in the domain of the function f. And so what that tells me is that the critical number for number 29 is negative 1/6. Let's take a look at problem number 31. Now, on problem 31, f of x equals 3x to the 4th plus 8x cubed minus 48x squared. The domain for problem 31 is negative infinity to infinity. And so I want to take the derivative here. F prime of x is 12x cubed plus 24x squared minus 96x. Now, we're going to do a little work here. So I'm going to factor out the 12x. And when I do, I get x squared plus 2x minus 8. But x squared plus 2x minus 8 can be factored. And so when I do, I get 12x times x plus 4 times x minus 2. And I'm going to set f prime of x equal to 0. And so that says 12x times x plus 4 times x minus 2 equals 0. And so when I solve for x here, I get x equals 0, x equal negative 4, or x equals 2. And I want you to notice that 0, -4, and 2 all belong to the domain of the function. And so what that tells us is that the critical numbers for problem 31 are 0, -4, and 2. And that's problem 31. I want to show you problem number 37. 37 is a great question. Now, on problem 37, we have P of x equals x squared plus 2 divided by 2x minus 1. Now, the domain here. So it's very important that we're mindful of the domain. Here, it's going to be negative infinity. Let's give ourselves room here. So it's negative infinity to 1/2, right? Because at x equal 1/2, the denominator ends up being 0. And we're going to union that with 1/2 to infinity. Now, let's go ahead and take the derivative. P prime of x, so we're going to use the quotient rule here. So I'm going to write down the bottom function, which is 2x minus 1. I'm going to take the derivative of the top function, which is 2x. I'm going to subtract the top function, which is x squared plus 2, times the derivative of the bottom function, which is 2. And I'm going to divide by 2x minus 1 raised to the second power. So I want to simplify P prime of x a bit. So 2x times 2x is 4x squared. 2x times 1 is just 2x, so I'm going to write minus 2x. And then I'm going to subtract 2x squared, and then subtract 4. And I'm going to divide by 2x minus 1 squared. So we're going to take this a step further here. So therefore, P prime of x is, now the denominator is 2x minus 1 to the second. The numerator is 2x squared minus 2x minus 4. And I'm going to factor out a 2 from the numerator, and I'm going to get x squared minus x minus 2. And in the denominator, I get 2x minus 1 to the second. So we're doing a little bit of work here, but it's going to pay off shortly. Now, this is 2 times x minus 2 times x plus 1 divided by 2x minus 1 to the second. So we're going to look at two situations here. Now, P prime of x equals 0 when 2 times x minus 2 times x plus 1 equals 0. And so therefore, P prime of x equals 0 when x equals 2 or x equals negative 1. Now, this is the one that's interesting. P prime of x does not exist when x equals a half. But we need to check something here. Now, when x is 2 or x is negative 1, notice that both of those numbers lie in the critical, in the domain of the function. Okay? But when x is a half, notice that it's not in the domain of the function. And so therefore x equal half cannot be a critical number. And so let me write that down. X equals a half is not a critical number because 1/2 does not lie in the domain of the function. And so for problem 37, the critical numbers happen to be, looks like 2 and -1. And that's how 37 works. I want to take a look at problem 39. So on 39, we have h of t equals t to the 3/4 minus 2t to the 1/4. Now, the domain of this function is going to be 0 to infinity. And 0 is inclusive because it is illegal to take 0 to the 1/4, and it is illegal to take 0 to the 3/4. That is legal, okay? Now, let's take a look at h prime of t. That's 3/4 t to the -1/4. That's just power rule. Minus 1/2 t to the, looks like, -3/4. So we're going to do a little simplifying here. So this is 3 over 4t to the 1/4. Let's write that a little better here. Minus 1 over 2t to the 3/4. Okay. And I'm going to do the following. So let's multiply. We're going to do this. So h prime of t is, now I'm going to multiply this first term, the numerator and denominator, by t to the 1/2. So I'm going to get 3t to the 1/2 divided by 4t to the 3/4 minus. Now I'm going to multiply in the second term the numerator and denominator by 2. So I get 2 over 4t to the 3/4. And so in the denominator, I get 4t to the 3/4. In the numerator, I get 3t to the 1/2 minus 2. Yeah, okay. So that's just getting a common denominator, doing a little simplifying, things of that nature. Now, h prime of t does not exist when t equals 0. Now, h prime of t equals 0 when the numerator is 0. So in other words, h prime of t equals 0 when 3t to the 1/2 minus 2 equals 0. Now we're going to solve this for t. So 3t to the 1/2 minus 2 equals 0. So t to the 1/2 equals 2/3. So I added 2 to both sides and then divided by 3. So if I square both sides, I get t equals 4/9. Now the question, does 4/9 belong to the domain of the function? The answer is yes. Is 0 in the domain of the function? The answer is yes. And so what that tells me is that the critical numbers for problem 39 are 0 and 4/9. And that's going to conclude this video for section 4.1, where we worked on problems 29, 31, 37, and 39. Thank you.